Welcome back. This is the mini lecture for Chapter 9, the second chapter on economic growth, um, exogenous growth. Okay, where we left off last chapter was with the Solow model, showing that there is a steady state of capital per worker where the amount of capital you're losing each time period, delta, times the amount of capital you have, is exactly equal to the amount of capital you're replacing each time period, which is S, the savings rate, times output, which is just a function of capital per worker. Then we added to it the possibility of population growth. Because we were measuring things in per worker terms, if the population changes, that's going to change the capital per worker. Now we're going to add one more term. We're going to add technological growth. My experience in teaching this course before is that students have a little trouble getting their head around this. Measuring output in per worker terms, that's not too hard to understand. But think of it this way. Things about workers change other than just how many of them there are. If you double the number of workers, but everything about the workers stays the same, well, that's double the labor power, in a sense. Double what they can do, the output they can create, because you have twice as many. But imagine instead of doubling the number of workers, you kept the number of workers the same, but you doubled how good they are, how effective they are. Well, then that would also increase output. That would double, in a loose sense, the output of the economy. Actually, a little less than double, but so you can increase the amount of labor power you're applying by increasing the number of workers or by increasing the quality of the workers. Here, production was, in these models, a function of total capital, total output, a function of how much capital you have and how much labor you have. Now we're adding this term, E, how effective these workers are, their quality, essentially. So this is the number of workers times how effective they each are. So L times E becomes the number of, and we call this the number of effective workers. This is the bit that students sometimes have trouble with. We're not dividing by number of bodies. We're dividing by, in a sense, quality adjusted bodies. Okay, now if we convert to a per worker measure, divide everything through by L, like in the Solow model from Chapter 8, but we include this concept of effective workers. How many effective workers do you have? Well, we shouldn't divide through by L anymore. We should divide through by this whole term, by the number of effective workers. So if your workers get better, this term increases. So now output per effective worker is lowercase y, and lowercase k is capital per effective worker. Everything is just converted to being in terms of effective workers. Now, this means that your steady state is going to change, the steady state condition. If you do not allow for population growth or change in the quality of workers, then your break even is when the marginal product of capital equals delta, the depreciation rate, times the amount of capital you have. That's how much you have to replace every time period. If you allow population growth, because it's all in per worker terms, then you have to also replace capital for these new workers to keep the level of capital per worker the same. Now we're in capital per effective worker. So if workers become more effective, to keep the level of capital per effective worker the same, you still have to replace capital that was wearing out. You still have to have new capital for the new workers, and you need more capital for the new effective workers. So this becomes your break even. And this term in the graph, you get G in there, which is the growth rate of effectiveness of workers. And now capital per effective worker on the horizontal axis. Now, what is G? What is the growth rate of effectiveness of workers? That's technology. In econ, technology has a particular meaning. In normal English, technology means, well, stuff like this, or like the computer that you're watching this on, or biotech, or whatever. In econ, technology is usually defined as, imagine all the things in an economy. Remove capital, remove labor, everything else is technology. So, the knowledge of how to create an integrated circuit, yeah, that's technology. It means that in English too. But in econ, a legal system is technology. Is it capital? No. Is it labor? No. Therefore, it's technology. Cultural norms are technology. Religion is technology. Here we're using a very simplified version where it's a little bit more like the English use of the word. It's anything that lets workers be more productive. That's not capital. So, you get a new golden rule level of effective capital per worker in a steady state. I want to go back and comment on this. In the non-golden rule version of this graph, this was level of capital per worker. Only one of them was this steady state. This is a different graph. This one, although they look very, very similar, notice there's no S here. This one is showing all the different possible steady states, depending on the savings level. If you have a low savings level, you could have a steady state there. High savings level, you could have a steady state there. These are all steady states. This one is just the steady state that you prefer, because it's the one that maximizes consumption. And all of these extend to the new conception of effective worker, and that is the steady state, and this is the study of those steady states. This is the one you prefer. Let's see. Okay. The Solow model predicts, because there's declining marginal product of capital per effective worker, it means that countries that have a lot of capital, speaking broadly, should grow, because here growth, economic growth, is determined by the term G, the rate at which your technology improves, which is also the rate at which your workers become more effective. If a country already has a lot of technology, adding more is going to help some, but not a tremendous amount. If a country has very little capital, adding 1 unit of capital should have a very large effect on output. This means that poor capital you should get essentially more bang for your buck by investing capital in poor countries, because they're the ones who really need capital and can make best use of it because of the declining marginal product. If you invest capital in a country that already has tons of it, it's not going to have all that much of an effect. And since the return to capital is its marginal product, if you invest your money and you want the highest rate of return, you should put it in poor countries, because it'll have the biggest effect on output and thus biggest return to your investment. Well, this means if you can get a higher rate of return that this model predicts in poor countries than in rich countries by investing your capital there, then capital should flow from rich countries to poor countries where the marginal product is higher. Is that what we see in the real world? I think you know the answer is no. The model assumes that would happen if all else was equal, ceteris paribus in Latin. But all things aren't equal. There are all sorts of other things that determine economic growth and thus the return to capital. Cultural differences. All the things that I said before are technology in a sense, in the economic sense. Here's one. Risk premia. If there's a 20% chance in each year that the government of the country where you invest will simply take your capital, you're going to demand a higher rate of return before you're willing to invest there. The Solow model predicts, since capital will flow from high capital countries, rich countries, to low capital countries, poor countries, because the marginal product of capital is greater there, that would mean that low capital countries, poor countries, should grow faster than rich countries. Well, if poor countries grow faster than rich countries, it means eventually they'll catch up. Conditional convergence. That the gap between rich and poor countries should shrink over time. That's largely not what we see. That does not mean the Solow model is wrong, or the Solow model augmented with population growth is wrong, or the Solow model augmented with population growth and technological growth is wrong. It just means that doesn't model everything there is in the economy. There are more complicated issues determining economic growth. Um, oh, let's see. Policy issues, some calculations suggesting that the United States is saving at an inefficiently low level, that we are below the golden rule or consumption maximizing savings rate. Oh, let's see here. Institutions, legal institutions, efficient capital markets, lack of corruption. These are all technology in the economic sense very broadly. Are these important? Yes. This is a famous photograph. This was taken by a satellite in the visual spectrum, so it's showing natural light, and it was taken at night, which is why most of it's black. These lines were added afterwards. They're just countries' borders. This here is South Korea. This, which you can't see in that highlighted color, how about that? This is North Korea. Capitalist. Hardcore communist. Relatively good institutions. Really bad, I'm saying bad institutions. Good and bad are not economic terms. The institutions in South Korea are efficient. That is an economic term. The institutions in North Korea, profoundly inefficient. I can say that as an economist, and I doubt there's one economist on earth who would disagree with me. Well, maybe there's a North Korean one. As a human being, not as an economist, I can also say that the institutions in South Korea are good. They are moral. My personal opinion, and the ones up here, you know, with the gulags and the mass murders and all, are not good. That's not an economic statement, but I'm making it anyway. Normally I leave that kind of stuff out of economics classes, but here it's just so obvious. This is a fascinating paper. It's a great example of a particular econometric technique that leads to a fascinating result, and it's also fascinatingly wrong. The statistical modeling is I love statistics. I just do, and econometrics. There are problems in this statistical analysis. Still a brilliant paper. Its conclusion still may be right, but the way they proved it is not correct. Here's a good question. The Solow model, which is very useful for a lot of things, I don't mean this is a criticism of it. It's predicated on the assumption that there is declining marginal product of capital. But is that right? We know there's declining marginal product of most things. Whatever it is you have, if you have a ton of it, getting a little bit more is probably not going to help you as much as getting your first few units. But is that true with capital? If you define capital broadly and you include intellectual assets as capital, if you include brilliant ideas as capital, then probably capital does not have a declining marginal product. if it probably has increasing marginal product. Think about it this way. I have one brilliant idea, and I can give it to two people. Person A currently has no brilliant ideas. Person B currently has hundreds of brilliant ideas. And I can give this brilliant idea to one or the other as I choose. Which one would increase their output more with this new brilliant idea? Not the person who currently has none. Give them a brilliant idea, their production would go up. But if you give a brilliant idea to someone who already has 27 brilliant ideas, there's going to be interaction between them. The total is going to be more than the sum of the parts. That new brilliant idea will make all the other pre-existing brilliant ideas even better. Output is going to go up more for that person than for the person who doesn't have any brilliant ideas currently. So, because knowledge interacts with knowledge. It's like a network effect, if you know what that is. If not, look it up. Google's your friend. If this is true, then it would explain some of the things we see in the Solow model that don't match the world we look at. Poor countries don't grow faster generally than rich countries. Anyway, so that's still an area that we're thinking about as economists. And I think that does it for this chapter. Thankfully, I've kept this mini lecture a little more mini, and I will see you next time.